Okay, question number 8. The car moves in a straight line. So this is either SUVAT or 3-line multiple choice boxes. Its velocity is given by this formula. There's no reason to think the acceleration is constant, so I better not use SUVAT. The 3-line multiple choice box method is super safe. It works for everything, just not all that simply. If you can use SUVAT, then use SUVAT as long as it's legitimate. But here I'm going to be safe because I've got no reason to think that the acceleration is constant. Now, the V is the second row of the multiple choice box. And by the way, if you're just watching this video for a hint, you should stop now and do it yourself. I'm going to work out the top row and the bottom row and then answer the question. So here I go. The bottom row comes from differentiating that. That'll become blank. That times that is -3/8. So there we go. The acceleration is not constant, so I was right to think that I shouldn't use SUVAT. To get up the table, you integrate. I'm terrible at these. Whenever you have k x to the power of n, integration will produce k over n plus 1 x to the power of n plus 1. So what's my k here? An eighth. So I've got -8 t3 will become negative over 8 3 plus 1 t 3 plus 1. So that's -8 divided by 4 is -1/32. Now I forgot to draw a diagram. Car just moving in a straight line. So let's say the displacement there is 0. The displacement is always just relative to an initial point, so there's nothing wrong with doing that. It's point B over here. There's no suggestion that it turns round, just starts out there. Is so it comes to rest there. The velocity, it comes to rest there, so the velocity is 0. At t equals 0, its velocity is 27, so it's going pretty decently fast in the positive direction. So that's the positive direction there. And that's positive displacement over this side, negative displacement will be over that side. I'm just getting my story straight here. C has to be 0 if that's the reference point. Because if t equals 0, then s equals 0. Because we're just setting it up that at the start, in other words t equals 0, it's at the reference point A, so therefore its displacement from the reference point will be 0. Okay, so now I'm going to answer the question. Show that the car is at B when t equals 6. Okay, well, I'm going to substitute in there, because it said that it was at rest, that's the crucial clue. Times everything by eight. Double that once, 54, double it again, 108, 216. Do the cube root on a calculator for that and you get t equals 6. That's Roman numeral part 1, nice and quick, as indicated by the fact that it was only worth 1 mark. Now find the distance. A to B. Well, as long as there's no hint that it turns around again. So just because it comes to rest there doesn't mean that it doesn't do something strange in there. It could go like this, turn back on itself and then press on towards the end. But if it did that, it would have to come to rest more than once, and it can't come to rest more than once because that only has one solution. We just found it there. So it comes to rest only once at B. So all we need to do is substitute t equals 6 into this one. And then out pops the answer, which is 121.5. Now the reason why that's worth 5 marks is because it involves doing the integration to find this top row here, which I did when I was getting my story straight before. So anyway, that's the answer to Roman numeral part 8. Have to do the units.